Hello, welcome to the second day of 12.1. Today we're going to be looking at what happens when we have paired t-tests. That's when we have a matched pairs situation, and we want to use a t-test because we don't know the population standard deviation. Well, we're just going to do two examples today, and that's our whole lesson. We hear that listening to Mozart improves student performance in tests. Perhaps pleasant odors have a similar effect. To test the idea, 21 subjects worked at paper and pencil maze while wearing a mask. The mask was either scented or unscented or carried a floral scent. The response variable is the average time on 3 trials. Each subject worked the maze with both masks in random order. The randomization is important because the subjects tend to improve their times as they work a maze repeatedly. Here are the results. So these are the times for unscented, and here are the times for scented. Now, alright, so we want to test whether or not the scented masks decrease the time it takes to complete the maze. Our hypothesis will be that our null hypothesis, the mu, is equal to 0. Because what we're going to test is that if we put these into L1 and L2, now take a second and pause the video and put the unscented in L1 and then the scented in L2. And then what we want to do is take L2 minus L1 in our L3. And what we're going to test is our L3, what the difference between the two. So if we look back here, if I take scented minus unscented, we want this time to decrease. We want scented to be less time than unscented, because we want to see if the scented decreases the time it takes to do the maze. So scented minus unscented, we want to be a negative value. So since we want that negative, in order for us to see that scented decreases times, we'll want our null hypothesis, mu, is less than 0. Now we have to define mu. Mu is the average time it takes to, the average difference of time. Difference is a key word to have here. The average difference in time to complete a maze with scented versus unscented masks. Alright, now we have to check the conditions. Does it say data comes from SRS? It just says 21 subjects. So data does not come from SRS. For normality, we have 21 subjects, which isn't enough for central limit theorem, so we'll need to graph them. So what we'll want to do is graph your L3 and look at that box plot. So let's take a look. Now the graph on this looks really symmetric. So if I drew out this box plot, it would look something like that. So data is approximately normal. because box plot is symmetric. Now for independence, we just have to assume that each person's each trial is independent. We're not really sampling without displacement here, so we really don't need that n is greater than or equal to 10 times little n. All right, now we look at the calculations. Now we do the same thing that we did before. We take our x bar plus or minus t star times s over the square root of n. Our x bar is, oh no, what am I doing here? That's not what we did before. We're doing a test. Our t-test is x bar minus mu over s over the square root of n. I started doing a confidence interval for some reason. Alright, so the mean is 0.9567 minus our null mean of 0 divided by s, which I got 12.548 over the square root of 21. Now when I do this all out, I get 0.349. 0.35 is probably good enough. So now we want to find the p-value. So we could do the p-value from the chart, or we could do a t-CDF from 0.35 to a very large number with a degree of freedom of 20, and the p-value would be 0.365. Now we interpret this. So the p-value is high, so we'll fail to reject the null. So we fail to reject the null hypothesis because the p-value is too high. So we do not have evidence that scented masks increase or decrease the time to finish a maze. All right, so that's a confidence interval, or not a confidence interval, match pairs for a significance test for a match pairs. I can't really talk, but hopefully you understand what we actually did. So we started with hypothesis, went to conditions, calculations, and then we interpreted. Not much different than we previously did. The only thing that's different is we have two sets of data, and we have to subtract them to get our third set of data in L3, and then we use our L3 to do our t-test. Here's a new one. I want you guys to read this and then try it on your own, and then take a look and see what I've done. The research is studying vitamin C content that could be destroyed as a result of storage and shipment of the commodity to its final destination. The researchers specially marked a collection of bags at the factory and took a sample of each of these to determine the vitamin C content. 5 months later in Haiti, they found especially marked bags and took samples. The data consists of 2 vitamin C measures for each bag, one at the time of production in the factory and 5 months later in Haiti. Here are the data. Is there evidence that vitamin C is destroyed as a result of storage and shipment. Okay, from here, take a second, um, go through this significance test, and when you're done, take a look and see what I've done. Alright, now to start up this problem, the first thing we have to do is look at our hypotheses. And I said that my null is equal to 0, meaning that the difference of vitamin C is nothing. And if I have a null less than 0, that means that vitamin C has been destroyed. So I looked at my conditions. Data does not come from an SRS. Data are approximately normal because the box plot is symmetric, and we have to assume that each observation is independent. Now, it doesn't really make sense to do the n is greater than or equal to 10n in this situation because we're not sampling without replacement. Oops, something else is starting up here. All right. So here we do our t-test statistic, where we take x bar minus our null mean over s over the square root of n. These two numbers I got from one variable stats of my L3, and then we got a p or a t score of negative 5.3. So that's such a large t-score that our p-value is essentially 0. So now our interpretation is we reject the null hypothesis because the p-value is so low. We have evidence that vitamin C is destroyed in that process. Alright, hopefully this makes sense on how to use our t's in match pair situations. And here are 3 problems to do. Good luck.